Good morning, class. I hope you did well on your math workshop test and your quiz. I hope you made me proud. I hope it wasn't too bad for you this morning. Also, I want to take the time to wish everyone who's taking the ACT tomorrow good luck. Believe in yourself. I believe in you. Make me proud. Make yourself proud. Use the strategies that we've been learning in class, and you would be awesome. Okay, you would do awesome. Just know that I'm proud of you, and you're going to do great tomorrow. Alright, what we're going to do first, guys, is we're going to look at our homework. And you can go and get your homework out. That is page 13. We're going to look at numbers 32, 35, 38, and 39. And that reviews our learning target that we did yesterday. I can graph logarithms. Our learning target from yesterday was I can graph logarithms. The day before we evaluated logarithms, but now we're going to graph them. At this moment, all cell phones need to be placed away out of sight. You need to put them in your book bag, but they do not need to be out. Make sure they are away at this moment. Alright, so let's review something here. This is the parent function exponential y equals base raised to x. We know this is exponential because your variable is in the exponent spot. And we know that domain for that is all real numbers and the range is 0 to infinity. Well, the inverse of exponential is logarithmic. Y equals log base b of x. And we learned that since these are inverse, your domain and range are swapped. So if the domain over here is negative infinity to infinity, that is the range, and then vice versa, your domain is 0 to infinity. Now let's talk about a little bit of why your domain is 0 to infinity. Let's look at this. Notice that the value next to b is your x. So if you look at this, if I have log base 10, 10 raised to 2 gives you 100. 10 raised to 1/2 gives you square root of 10. 10 raised to negative 2 will be 1 over 100. This right lets you know why. You notice none of these values are less than 0. That's why your domain. Logarithms are not defined for negative numbers. Okay? So looking at number 32. We have y equals log base 3 of x plus 1. Remember, when you graph logarithms, your 3 points, you use 3 points. 1 over b comma negative 1. 1 comma 0. And b comma 1. Alright, so now, I know that there's something going on. There's a transformation going on. This plus 1 is inside. We're going to come and take care of that in a moment, but right now we just treat it like that was not there and just look at this base, 3. So my 3 ordered pairs will be 1 over 3, negative 1, 1, 0, and 3, 1. Alright? Now this is affects your x because it's on the inside, so I'll move it left 1. That means add negative 1 to each of these. So 1/3 plus negative 1 will be negative 2/3. Negative 1 plus 1 is 0. 3 plus negative 1 is 2, 1. Now I would graph that. Negative 2/3. Now, you know in logarithms your range is all real numbers. Don't have to worry about that, but your domain, let's see here. Okay, normally your domain is 0 to infinity, but since this affects your x, move it left 1, that's going to be, instead of 0 to infinity, negative 1 to infinity. So it's getting very close to negative 1, but it never passes that. Alright, let's look at 35. y equals log base 1/2 x plus 1. Okay, if I use my 3 points up here, first one, I'm going to pretend this other stuff's not here, plus 1's not here. 1 over 1/2, 1 over 1/2 would be 2. Then you got 1, 0, and then 1/2 to 1. That plus 1 is on the outside. It's not a parenthesis, so it affects your y, so I'm going to add 1 to each of those. Okay. Now, that 1 did not affect my domain. So, my domain would be from 0 to infinity, and your range is always near infinity to infinity in a logarithmic. Now, I'm going to graph that. Can I go past 0? Okay. I'm going to look at one more. I'm going to look at number 38. We have log base 2 of x minus 1 plus 2. Okay, I'm on focusing on just on 2 right now, so that would be 1 over b, which is 1 over 2, negative 1, 1, 0, and 2, 1. We have 2 transformations going on here. That's moving it right 1, which is going to add a positive 1 to my x values, and the up 2 to add 2 to my y values. So that's going to be 1 and 1/2. Negative 1 and 2 gives me 1. 1 and 1 gives me 2. 0 and 2 gives me 2. 2 and 1 gives me 3. And 1 and 2 gives me 3. I added 1 to my x's first, and then went back and added 2 to my y's. And then I'm going to graph this. Now before we graph it, we can predict the domain range. You know the range on this would be all real numbers. Now your domain, there was something affected, moved it right 1, so from instead of 0 to infinity, it will be 1 to infinity. Okay. Does not go past that 1 line. X equals 1. So that was your homework. If you have any more questions, I'm going to review some of this on Monday. But now I want you to get your note taker out and turn to page 5. Your note taker, page 5. We're going to do the last 2 first and then come back to that top part. But I'm going to talk about these 2 problems right here, number 14 and number 15. Up to this point, you could do everything that I gave you in your head. Like if we had, I'm going to make one up, log base 8 of 64. You could say 8 to what power gave you 64? That was 2. Those were easy. But what if I give you something log base 5 of 103? We don't know off the top of our head what 5 raised to what is 103, some decimal. So you have to have another technique, another strategy to use for this. And what you use is called the change of base formula. Change of base formula. And what you do is you simply rewrite it as log of 103 divided by log of 5. You take the log of this divided by log of 5. You said, Mr. Church, what's the base of this log? Well, the base is 10. You turned it into a common logarithm. So you're going to say log of 103 divided by log of 5, and you're going to get a huge decimal. Let's see what we get here. Okay, so I'm going to use log. I press log, button right there, of 103 divided by log of 5. Hit enter. I'm going to have 3 decimal places, so that would be 2.879, but that's 7 rounds that 9 up, so that's going to be 2.880. 2.880. Number 15. Off the top of my head, I do not know 6 raised to what is 7,123. So I'm going to rewrite that as log 7,123 divided by log of 6. And I get 4.951. Okay. So that is the technique you use. If you cannot do these in your head, you use the change of base formula. Change of base formula. Now let's go up here and look at properties of logarithms. You studied this last year. You studied the product rule, the quotient rule, the power rule, and we just talked about change of base. So we're talking, but these 3 rules. If you see a logarithm where 2 things multiplied together, it can be rewritten as a sum of logs. Log base b of x plus log base b of y. That is known as the product rule. I took these 2 things, split it up with a plus. That is the product rule. Here's a numerical example. I can do this. This is log base 2 of 4 plus log base 2 of 8. Here's another example. These 2 are multiplied together as product. Break it up. Log base 3 of 3 plus log base 3 of x. Now, for division, it is the quotient rule. Quotient rule. You can rewrite this as log base b of x minus log base b of y. This is log going over here. This is division. I can write it as rewrite it as subtraction using the quotient rule. Log base 2 of 8 minus log base 2 of 4. Here, I can rewrite this one as log base 3 of x minus log base 3 of 3. So basically the product rule says if 2 things are multiplied, you can rewrite it as a sum. Quotient, if it's written as quotient, you can rewrite it as a subtraction. Now the power rule, if you remember from last year, says if something's raised to a power here, you can bring this power down from the log. So it's y log base b of x. Brought that down. So for example, you see this 3 here, you bring it down in front of the log. So if you ever see a number sitting right here, it's really the exponent to this term sitting here. Here I bring that 2 down to log base 6 of m. Okay. You can pause it for a minute if we need to. Alright, so today our goal of this lesson is to expand and condense logs by using properties of logarithms that we just learned. So it's just write as a sum or difference, expand. When you see the word expand, that means you want to get larger. So I want to look at number 1. I want to expand this. Well, that's all multiplication, so I'm going to use the product rule. So let's break that apart. Log 12 plus log x to the 5th plus log y squared. So I broke that apart with plus signs, addition, making it a sum. But I cannot submit this because I still got those exponents there. So what I need to do is bring those exponents down in front of the log. And that would be my final answer. Now let's look at number 2. I want you to correct this. This radical should be extended all over the 4x plus 1. Now I know that we're going back to this. I know there's not a little base on these laws, but when a number is not there, it's understood to be base 10. Base 10 logarithms are known as common logarithms. Now working with natural log. So what's our base here? I hope you said E, because it is. Alright, now, this is division, so I'm going to use the quotient rule. So, alright, ln x squared minus ln square root of 4x plus 1. Alright, now, we know we're going to take care of this 2 and bring it down here. So that's 2 natural log x minus. But can we rewrite this radical using the exponent? Yes, I hope you're thinking that. Because we don't need to keep that radical in there. But I can rewrite that as 4x plus 1 raised to the 1/2. Remember, when you raise something to 1/2, that means you're taking the root. So now I'm going to bring that down in front of this. 2 natural log x minus 1/2 natural log of 4x plus 1. And that is my answer. So if you have a radical, you got to rewrite it as the exponent. We're going to go down to number 4. Okay? This is quotient. You see, this is quotient. We're going to come back to 3 in just a minute. We're going to do number 4 first. This is quotient. I'm going to rewrite that as natural log. You said, Mr. Fisher, did I need to split the 3 by 2? No, it's combined by plus. There are no pluses up here, so you have to separate everything. But this is plus, so you keep it together. 3y plus 2 minus the natural log of the cube root of 3. Okay? Can't do much here, but I can rewrite this as y to the 1/3. And then bring that 1/3 down. And that would be my answer. Okay, let's go back to number 3. This is product rule. There's no plus, I need to break everything up somewhere. Log of 13 of 6 plus log base 13 of a cubed plus log base 13 of b plus log base 13 of c to the 4th. Now I clean up and bring all these exponents down. So I got log base 13 of 6 plus bring that down 3 log base 13 of a plus log base 13 of b, bring the 4 down in front, log base 13 of c. Alright? Looking at number 5. Looking at number 5. There's no plus in the middle of this, so you do need to break this up. Alright. So I'm going to go log x cubed. Now this is multiplication between these two. So you're going to keep a plus log y to the 4th. Then we go to division, minus log z to the 6th. So let's go like this. This is multiplication, that's why there's a plus between these, and then division. Then I'm going to bring the exponent down. Okay? Let's look at the last one. I'm going to have log base x. This is quotient, so I'm going to do minus log square root of x minus 1. I do not want to leave that radical there, so I'm going to rewrite it as an exponent. Log x minus log x minus 1 to the half. Bring that 1/2 down, and that is our answer. Today we're going to focus on expand. I think that's enough for the day, expanding. But on Monday we're going to talk about condensing it. going from this back to something small like this, okay? So make sure you just look at those and look over your notes this weekend, and we will continue with this on Monday.